Share screen. Okay. So what IR or infrared spectroscopy will tell you is what functional groups are present in a molecule, right? Usually an unknown molecule. And people in lab use this just to confirm or see what functional groups are present in the molecule, right? So if you see like the x-axis here, that's gonna be in like inverse centimeter units, right? And then they're gonna shine like infrared light through the molecule, and then they're gonna show like the absorbance of the molecule, right? And you know how if molecules have different functional groups in different areas, those functional groups are gonna absorb that infrared light differently. So that's gonna lead to different peaks of the IR right here, right? So I would recommend writing this down on your note card for sure if she asks you to tell what functional groups are present in the molecule, or if she gives you a molecule, what peaks would you predict would show up on the IR based on the molecule's functional group, right? So it could go both ways. If you see a peak at 1500 and below, we call that the fingerprint region, right? So we basically ignore that. Those are the single bonds. These are vocab conceptual questions that you can see on Leaven's quizzes or like final, right?
Okay. Yeah.
If you see a sharp peak at 1600, around 1600, that's gonna be the alkene functional group, which is a carbon double bond carbon. If you see a sharp peak at around 1700, which is very close to 1600, that is a carbonyl functional group, right? Which is a carbon double bond oxygen. That's a big umbrella term for many other functional groups. Like it could be an aldehyde, it could be a ketone, it could be any other things too. It could be like acyl halide, ester, amide, right? Like any functional group that has a carbon double bond oxygen, aka carbonyl, will be a sharp peak at around 1700. Okay, and now if you see any peak between 2100 and 2300, I call that the triple bond region, where we have either an alkyne, a carbon triple bonded to another carbon, or a nitrile, a carbon triple bonded to a nitrogen, right? Both of these have triple bonds, which is going to be in the triple bond region, 2100 to 2300. Okay. Now, the 3000 peak right here, you're mostly going to see most molecules having this peak because this 3000 peak represents an sp3 carbon to hydrogen bond, right? So if you have something like this, like let's say we have this molecule over here, this carbon's hybridization is sp3 hybridized. So if we are labeling this bond right here, that bond is in between an sp3 carbon, because like we said earlier, this carbon is sp3 hybridized to a hydrogen, right? So if any molecule has this bond right here, which most molecules do have that bond, an sp3 carbon to a hydrogen bond, that's gonna show up as this 3000 peak like that, right? Which most molecules will have. Okay, a molecule that would not have that peak, for example, would be benzene, which is this aromatic ring right here, because none of these carbons are sp3 hybridized, right? All of these carbons here are sp2 hybridized, right? So this bond right here, which is a bond between a carbon and hydrogen, is not a bond between an sp3 carbon and hydrogen, right? So because we don't have an sp3 carbon to hydrogen bond, we will not have that peak if we shine like infrared light through this benzene ring, right? This is an sp2 carbon to hydrogen bond, so that's going to be shown here, right, as a small sharp peak at around 3100, so a little bit to the left of the 3000 baseline peak that we would usually see, right? A little bit to the right of it, if you see a sharp peak at 2700, that's gonna be shown as an aldehyde functional group. That shows that you have an aldehyde present in your molecule, and this will always pair up with one other peak, which is this peak right here. So if you have an aldehyde in your molecule, like let's say your molecule is something like this, the IR of this molecule will always have two peaks paired together. This aldehyde peak at 2700 and this carbonyl peak at 1700, right? Because the aldehyde has a carbonyl within it, so that's gonna have to like match up and pair with that peak right there. Does that make sense so far? Okay, that's good. So now let's move on to the more interesting region, which is like this region over here. If you see a big broad peak at around 3300, right, that's going to represent one of two things. It's going to represent an alcohol or a secondary amine, right? This one big broad peak here represents one hydrogen bond, right? And a hydrogen bond is going to be bonded to any of these three atoms, FON, right? Fluorine, oxygen, or nitrogen. That's why we see one big broad peak here to represent that one hydrogen bond, which is going to be a primary alcohol or a secondary amine. If you have a primary amine like this primary amine has two hydrogen bonds because this nitrogen atom has two bonds to hydrogen, right? Which is going to be this and this right here. So that's why we see a fang-like structure right here, which shows two hydrogen bonds. Okay. If you see a broad peak that merges with the 3000 peak like this, that's going to represent the carboxylic acid functional group. Carboxylic acid functional group. And when you have a carboxylic acid functional group, notice how we have a carbonyl within that carboxylic acid, right? Which means that when you have a carboxylic acid functional group, you would always see this peak as well. Okay. Okay. So now there's one more peak here that I want to talk about, which is going to be this sharp peak at around 3300, which would represent an sp carbon to hydrogen bond. So if we have some molecule like this, and we're something like this, and we're looking at this bond specifically, this bond is in between an sp carbon and a hydrogen, right? We know that the sp3 carbon to hydrogen bond would be this peak, and sp2 carbon with hydrogen would be this peak, and sp carbon to hydrogen would be this peak at 3300. And notice how this sp carbon to hydrogen peak is a terminal alkyne, right? So make sure you know the differences between a terminal alkyne versus an internal alkyne, right? So terminal would mean like the end of the molecule. So a terminal alkyne would be having the alkyne at the end of the molecule like that. Whereas the internal alkyne would be inside of the molecule like that. And notice how the terminal alkyne will have a hydrogen attached to it at the end of the molecule, which will give us this bond here, which is between an sp carbon and hydrogen, right? So a terminal alkyne will always have that peak right there at around, oh no, not this one, that's sp2 carbon hydrogen. This peak right here, around 3300, because it is at the end having a hydrogen. The internal alkyne will have no sp carbon to hydrogen bond, right? Because these carbons here have no hydrogens at all, right? So if you have this peak right here, that will always be paired up with this peak right here, at the triple bond region, 2100 to 2300, right? So if you have this peak right here and this peak together, you know that you have a terminal alkyne. If you just have this peak right here and you don't have this peak, then you could have an internal alkyne or a nitrile. Does that make sense so far? Any questions so far on that?
No.
Okay, that's good. Did she post any practice related to this IR?
Yeah.
Can you send that to me on Discord, please? Like the PDF?
Understand her PDF, one that I merged together.
Oh, you have one?
I sent it in the group chat, our group chat. I call it like DIY discussion set. I put like all the
right here.
problems in there.
Oh, that's so nice. Yeah.
Yeah, all the problems are on our quiz.
Nice. Let's
So,
see here.
that's like that other document has the answer keys with it. So
Oh shoot, I see that you forwarded it, but it's like grayed out for me.
Oh, it's grayed out.
Yeah, I think it's because I might not be in the server or the group.
Oh, okay. I can download it and send it.
Yeah. Thank you.
Did that work?
Yeah, I see it now. Thank you. Let me import it to this page.
Oh yes, somewhere in there.
We could work through that. Okay. Let's see. Ooh, okay.
I sent the answer key with it as well.
Okay, thank you for that. We could double check our work. But before we check it, let's try it first. Okay. Okay. Share screen.
No, I'm not.
Hyperkeys are really good at this.
Ooh, okay, okay. Chairs, stereochemistry, cyclohexanes. Ooh, okay, this one. Practice. Okay. This is the key.
The key document has the problems and like the answers.
Oh, at the end of the page. I see.
I don't know why I meant like that. Sorry.
It's okay. It's okay. I was like, where's the answers? Where are the answers? I see it. Wait. For this one, huh? Let's see. Okay, I don't see the answers for this one, but we'll go through this anyway. So 1500 and below, what is that region called?
Fingerprint.
Yep, fingerprint region.
It's okay. You wrote it down.
That's all of the single bonds?
Yeah.
Yeah. Those are the ones with the single bonds, like carbon single bond carbon, carbon single bond oxygen, carbon single bond nitrogen, carbon single bond like halogen, like fluorine, chlorine, or bromine. Like those are the ones with the single bonds. That's not really useful for us in IR, but you can still be asked for that because I've seen Levis ask for that still on her quizzes. But it's most important to know that that's the fingerprint region right there, because I bet that she will ask about this. What's this region called? And then she's gonna have it underlined right here, and then you're gonna have to say the fingerprint region.
Yeah.
Okay. Okay, so let's say this is 1500, right? And this is 2000. What's in between 1500 and 2000?
Oh, I forgot.
Math.
I know that's where it
Oh.
starts being double bonds. It was it CO first?
It's the C double bond O, because in between 1500 and 2000 is 1750, right? And then the closest to 1750 on here is going to be the C double bond O, the carbonyl, right? If the peak was closer to 1500, what would that be? Like if it was like right here?
That's the C double bond C.
Yep, the C double bond C, the alkene functional group. So these two are very close to each other, but you can make a difference between that from this line right here. It's kind of subtle, right? But this line here is 1750 in between 2000 and 1500. If it's like around that line, then that's C double bond O, carbonyl. If it's like closer to 1500, then it's gonna be C double bond C, the alkene. Nice. Now, do you guys remember this 3000 peak right here that's kind of jagged?
Oh,
It's the one with majority in them, and then that's SP3.
yeah, sp3 carbon bonds to hydrogen.
Yeah.
Yeah, correct. sp3 carbon to hydrogen.
I don't know, I had a good memory.
Yes, that's good. That's good. Like the first time you guys see this, right? You're gonna see other people not writing this chart down on the quizzes or exams. They're gonna write the chart on the discussion manual instead with the numbers, like 1700, C double O, like that.
I tried using that one, but it's like it's too hard to read.
It's too hard to read, right? Because it doesn't look like this, right? This one is like more visual for you to see.
Draw
Right.
your version of it.
Mm-hmm.
Yeah, so I can like
Good.
learn.
Yeah, this took like actually like multiple edits to make. This wasn't made in one try. Let's get. Let's go. And now, how about this one? What do you guys think this peak here is right here? This big broad peak, a little bit to the left of 3000.
That was. No, what was that? I know it was the. It was the. Was it the primary? I mean.
So the primary mean will be this double fang peak right here with 2 hydrogen bonds.
Oh, it's the one that has only one lone pair, so it has 3 bonds.
Yep, it's the one with only 1 hydrogen, so it's gonna have 2 bonds.
Oh no.
So if it has 2 bonds, we call that a secondary amine.
Oh.
Okay, that's easier to remember.
Okay, so
go to primary, then secondary.
secondary is the blue one.
Yeah, secondary is the blue one, right? It's kind of confusing because when you think of secondary, you think of 2, right? But if it's 2 R groups, not 2 hydrogens, right? If an amine has 2 R groups like that, then it would have to have 1 hydrogen to be neutral, like that. That is a secondary amine right there, right? So, or it could be an alcohol, right? Most commonly, it's gonna be an alcohol, but because we don't know what it is, you're gonna say this peak here is gonna be an alcohol or a secondary amine, right? Which can be represented like this. This squiggly line here just shows a fragment. Like we don't know what that R group is. Okay. Now what about this sharp peak here? A little bit to the right of 3000.
Yeah.
So what is the first thing that you guys are going to do first?
I'm gonna ignore what's before 1500.
Yep, correct. Ignore what's in the 1500.
Then I would look at where the peaks are occurring. I see that there's one a little bit before 3000. And then so that means that there's a sp3 alkane.
So are you looking at this peak right here?
No, the other one.
This one here.
Yeah, that's
Yeah.
sp3ch.
sp3 carbon 2 hydrogen bond. Yes, sp3ch. Nice.
And I see that there's one that's 500. Is that the triple bond that's spiked over there?
Yes, this peak right here is gonna be between 2100 and 2300, which is the triple bond region. And what 2 functional groups are going to be possible here?
Nitrile and alkene.
Nitrile or alkyne. Right. Alkyne is for triple bond. Alkene is for double bond. Alkane is for single bond. It's very similar, but there's a big difference.
Yeah, like sometimes I like forget.
Yeah.
The one that looks like a parabola is
Parabola.
secondary amine and alcohol.
So it's gonna be either an alcohol or secondary amine. So now we have our potential functional groups. Now, what would you do next?
Eliminate the ones that aren't there. So I would start off by crossing out the ones that have SP hybridized Wait, never mind. Wait, I didn't read. Okay, wait.
I would take out anything that doesn't have triple bonds in it.
Okay, so let's take out the ones that doesn't have any triple bonds, like that one, this one, and everything else has triple bonds. Nice, because we know that we have a triple bond here in the IR, so this one does not satisfy that IR, so we could cross those out.
Okay. And then
I think like cross out the ones where for the triple bond there's like a extra carbon on the other side because there's no terminal alkene peak.
Oh, terminal alkyne peak, like this one right here, right?
Yeah.
Right. So if we have a terminal alkyne, what peak would you expect? And where would it be? Would it be a
It's-
short or broad peak?
It's a short, sharp peak inside the parabola.
Like right here, somewhere.
Yeah.
To the left of 3000, we don't have that there. That's not there. So we can eliminate all the ones with the terminal alkyne. The alkyne at the end of the molecule, like this one, and that's it.
Yeah.
Wait, for that one, we crossed them out because
This one not there.
which one?
That black one.
Oh, the black one?
Yeah.
Oh, the black one is the terminal one. Okay.
Yeah, it's just like
Okay.
since the peak's not there, we can't have those because that's saying that it should be there.
Okay.
I don't guess.
Okay.
Like the terminal alkynes, we have this peak right here, which is the SPCH peak, which is going to be a sharp peak at 3300. We don't have that. So that's why we cross out the terminal alkyne.
Should we delete all the ones that also don't have OH in it?
Yeah. Wait, no. OH, right? That's going to be this broad peak right here. Like we said, this broad peak represents OH.
Oh, it's a or?
Situation. Yeah.
Or it's going to be secondary amine or an alcohol.
Oh, I would cross out the ones that have a double bond O because there's no carbonyl peak.
At around 1700, right? We don't have that peak right there. Right? So because we don't have that, we can get rid of this and that. Nice. Okay. Okay. And then
I would just say the last four are answers.
Wait. Oh, they are? Whoa.
yeah, because ether here, it can be represented by the IR really. This is an internal kind, which is good. This is a nitrile, which is good. This is alcohol. Oh wait, actually, no. We can eliminate two more things here. What two things can we eliminate?
The ones that wait, I don't know. Wait. The what is that called again? The the ether or ester. That's like
ether. Yeah, that's a big misconception. Ether and ester, but this one is an ether. ROR.
Oh, ether is like when you have an oxygen bonded to like.
Oh, okay, two different things. Oh, yeah.
I remember. I forgot what ester is.
Ester is gonna be the same thing, but with a carbonyl next to it.
Oh.
So ester. Yeah.
We're gonna put the functional group chart on our card.
Yeah. How'd you do on that quiz? The functional group quiz.
Oh, I just put it on my chart, so I was okay. But then that means I didn't memorize them.
I don't remember having a functional group quiz.
Oh no.
Oh wait, we did.
It was part of a bigger.
Was
quiz.
it type 2? Quiz 2?
Yeah.
Okay.
Okay, so it's the ether here is not going to be the reason why we eliminate these two. It's going to be a different reason why we don't eliminate those two, because the IR represents the functional groups present, right? What is this function? What does this broad peak here represent?
I'm saying alcohol or secondary amine, and then those two, it's not there.
Yes, it's not there. The ether can still be there, right? But that's not like if there was an ether here, that would be fine still. The reason why we're eliminating these two is not because of the ether, it's because it does not have this broad peak, the alcohol or secondary amine. Nice.
Is it because the ether is in the fingerprint thing and like that we don't care about?
Yeah. Yeah, the ether is gonna be the fingerprint thing because ether is gonna be a single bond between carbons and oxygen, like that. Like that's gonna be in the fingerprint region. That's a good catch. Right. So if you really wanted to like read the ether, it would be in the fingerprint region. Right, the C single bond O. But you don't need it in to do these problems here.
Okay.
Yeah, but like just know that because it could be tested conceptually. Like where would this bond show up as in the IR? And you would say the fingerprint region.
Okay.
Yeah. So our answers for these ones here, for this one here, is gonna be this or this right here. Right. The only difference is the alkyne or nitrile, but we don't know because it could be alkyne or nitrile for this sharp peak right here. Right. We can know if we are given the chemical formula, right? If the chemical formula has a nitrogen, what would the molecule be?
Wait, sorry, what did you ask?
If the chemical formula has a nitrogen, what would the molecule be? A or B?
B.
Yeah, B. It wouldn't be this one because this molecule has no nitrogen.
Yeah.
But because we're not given a chemical formula, we're open to either alkyne or nitrile.
Okay.
Okay. Any questions on that?
No.
Okay, that's good. Do you guys want to try Kahoot now on this?
What?
Yeah. Kahoot.
Oh yeah. Oh, Alina said she's okay.
Okay, that's good.
Yeah. Let's do that. Let's do that.
Let's do that.
This is gonna be fun. Let's see if you guys learned IR in like some few minutes really quick. You could use the chart. You could use the chart. This the one that you screenshotted.
Oh, how do I join the Kahoot? Oh.
I think it's Kahoot.it. Okay. I got the app. I forgot where the app.
Oh, let me download it.
You can do it on the website too if you want.
Actually, let me just look this and see so
What if we just sing?
Oh, we can. Wait, no.
Oh no, I got the koala.
Let me go get my.
Oh,
Sorry, let me go get my app.
You can change your avatar.
I like the tiger.
Tiger.
Oh, you could be a brain too. That's so funny.
Sorry.
Look, I'm like a. Oh, it's-
I need to use my mouth now.
Alright, we thought it's funny.
Oh, you guys are gonna do it together?
Sorry, I was joining my hotspot.
Oh yeah. No worries, no worries. I could make it bigger here. The QR code and the game pin.
Oh shit. Sorry.
Oh, I'm done.
Please, I wanna play. Okay, we might have to play this now.
Okay, yeah, we're just gonna team it together.
Okay. Sounds good.
So I chose to be a unicorn with rainbow glasses.
What's the question? What's the questions?
I'll put it here.
Oh. Wait.
That's like the high region, right? This is.
What's the question? Oh, no.
Oh, I just read. Okay. Is it like 3,000?
So this one here, it's asking like what bonds are found at the 3200 to 3400 in the IR spectrum. And if you look at the screenshot, right, of the chart that I gave you, you know the baseline peak is at 3000, right?
Yeah.
Is the 3200 to 3400 peak to the left or right of that?
The left.
The left, right. So that
And-
left, there's so much craziness going on there, right? That's gonna be like the amines, alcohols, and the sharp sp carbon hydrogen bond, like those ones right there.
Yeah.
It didn't include the sp2 carbon hydrogen because that's closer to 3000. It's gonna be around 3100.
Yeah.
Right. The other answer choices are wrong because where would green be? Where would the carbonyl and alkene bond be?
1,500.
Yeah. That's like from That's like from 1700 to 1500.
Yeah. More specifically, carbonyl would be 1700, alkene would be 1600. Right. What about the red? Where would you expect the red one be?
The CC and the CN, they're between 2100 and then 2300.
Yeah.
They're too
Nice.
low.
Nice. How about the yellow one?
That's like right after the baseline.
Yeah.
Right after the base, right? Which is around
3100.
3100. Right,
Oh.
and a little bit to the left of that, more left of that is like the craziness, the NH, OH, and SPCH.
It's okay, on the quiz you'll have more time.
Yeah. Okay. Yes.
Oh wait. Oh yes.
I was trying to check it out.
Oh, yeah, that's true. Okay, but the bad thing is I only know that's true because I saw that question earlier.
I can explain it.
That's not what I mean.
What do you mean?
Oh no, I kicked you out of the game.
Okay, we think it's true, but I got it in the game.
Oh, it kicked you guys out?
Yeah.
Oh wait. Join back. Join back.
1, 4, 8. Oh god. Oh god.
Oh no, it's okay. It's okay. So, do you guys understand why it's true?
Kind of. I know that the IR spectrum, it can't tell you like what's exactly in it, but you can match.
Yeah, like we were just going over an example earlier where it gave us a spectrum, and then you said if we knew the molecule, we would know like which one it was, and that's what I thought of.
Yeah. So IR will show you the functional groups present of a molecule. So if you have the exact same molecule, right, and you shine it like 2 times, you would expect the same IR spectrum. But if you had 2 different molecules, you would expect like 2 different IR spectrums.
Yeah.
Right. So if you if you're like given an unknown compound, and you already know like a compound from previous labs, right? And you shine an IR spectrum to that, and then in a new lab you get an unknown compound and you shine an IR spectrum through the unknown one, and if that IR matches the one that you know already, then you know that that unknown compound will be the exact same molecule as the known compound, if that makes sense.
Oh, wait, is this question just about how some molecules can have the same IR spectrum but like are different slightly?
Oh no, this is gonna be like how if the molecules are different, they will have different IR spectrums, like entirely, like different.
But some of them can have alcohols or amines and still have the same like peak.
Right, they will have the same peak, but they're not gonna be so they're gonna be similar in that terms, right? Like the functional group terms. But if you look at the single bond or fingerprint region, that's gonna be where the difference is.
Oh, okay. So this is just saying that if you have an unknown and you like look at it, you have to compare it to known one.
Right. Yeah, and that's a good point that you brought up, because if your unknown compound has like the same functional groups present as your known compound, right? They can still be different because the way they connect, like they could be constitutional isomers of each other, right? So to know if they're exactly the same is when you look at the fingerprint region, and then like each jagged peak has to exactly match. If there's some differences, then you know that they're not the same. But if they're exactly identical, like every single small, sharp, and broad peak matches the exact same way, then you know that it's exactly the same molecule.
Okay. I think I get it now.
Yeah. Let's get ready to move on to the next one.
Yeah. I know. I'm beating myself.
Oh, yeah.
The
Single.
Single. Yeah.
Finger.
Yes, and also known as what region?
Fingerprint.
Fingerprint.
I remember it because the cops couldn't find a single fingerprint on my stolen bike.
That's
The region that has between.
Nice.
The traumatic experience will help me. The CO double bond. Okay, that is like the beginning one. That is right after like 1500.
Be careful of this one. Like this, very close. Like don't choose too fast. Yes. Oh,
It's okay. It's okay.
okay. So for this one, right? Where is the carbonyl?
Oh, the CC comes first.
Yeah.
Mm-hmm. The CC comes first. The green one that you chose is the CC one. C double bond C. Yeah. The C double one O is 1700. Any questions on this one?
Okay.
Uh-huh.
Okay. Yeah,
Ready?
that makes sense.
Mhm.
Yeah.
So cool. Oh,
ACU double bond is different.
different. It has
Yeah.
different. It was the first. I don't even know how to spell.
Yep. They're very close to each other though. Very close.
It should say like Karina's iPhone.
Oh no, your guys' devices aren't working either.
Yeah, I think the Wi-Fi is out.
No. ACC triple bond is okay. So triple bonds they come like they're like between like the crazy stuff and like the double bond. Right?
Yeah. The
No, it's like behind 3000. I think it's this one. Oh.
Yeah.
Oh, I was clicking the screen. I was
Oh.
my iPad.
Yes. Nice.
A linear? I mean.
Uh, Start.
Curve, yeah.
Oh.
The only
Yes.
problem, really,
like the very end
is the
where it gets
FP
crazy.
and the yeah. Cool.
Nice.
My legs hurt. Walk in the rain. What kind of bond is a
Oh, wait. This is like way at the end, and it's like the tooth one. Oh, this is the one I struggle with. I think it's like
I think it kind of looks like a parabola.
yes, a parabola one.
OH and NH?
Yeah.
Yes, let's go. You guys got it.
Sorry.
It's been bad for them too. Even on your hotspot screen, the Wi-Fi is really bad.
Oh, I'm sorry. Maybe we can move in a second.
You're gonna go to
Oh,
what kind of bond does peak B represent?
what?
It's the
Oh.
spike.
Oh, it's
Is it-
SP2? Right.
I don't think so. B. It's like it's within the parabola.
Oh, that's SP. That's SP.
You're right.
Let's go. You guys are getting it.
Two, and then the other peak in the inside is SP. Okay.
We gotta learn it.
We're also See, I told you learn like so much about it. Which kind of bond was?
Oh, I think this is the SP.
I agree. But what if the SP? It's right on the 3. No, it's after the 3000. Yeah, it's the SP3.
The SP. Did I say 3 or 2?
Is it 2?
Oh, okay, I already forgot. The 3 is the weird one. The one that looks like 9.
Oh, yeah, it has a bunch of them. Yeah, you're right. Yeah, that's also like another way to distinguish it. That's the SP3.
CH.
Nice.
AE. Okay, so that one is at the triple bond
Is
stuff.
that
right?
outlier?
Nah, I don't see triple bonds. Oh!
Oh
no!
Oh.
Is that the double bond region? Wait.
Well,
Triple bond
okay, you
region.
got numbers. I'm sorry.
Wait, look at the numbers. Where is E closer to? Where is E closer to? 2000 or 3000?
I didn't read it.
2000. Where would you expect the aldehyde peak be closer to?
Closer to like 3000, like behind it, but like close to it.
Yeah. This one here is closer to 2000,
Okay.
so that's the triple bond region. Yeah, that's important. Look
Okay.
at the numbers on the actual IR.
What kind of bond was PF? Okay.
Nice. Okay, ready for the challenge? The
You just
final
said
boss? It's the final boss.
name.
Oh no! How do we figure out what it is?
Okay, you said that.
You got plenty of time for this one. More time.
Terminal. I know I can.
I know.
I'll bring it to
You know that this is triple bond with it, so we can talk.
Yeah.
Okay, so that doesn't really matter. So that means
It was.
okay, and then either wait, that one has a double bond. Okay, it has an alcohol, has
The internal alkene. Wait, what's the one with the Y called? How do you pronounce Y?
Alkyne.
Alkyne. It also has the terminal one.
Which was the terminal one? This peak?
B.
Okay.
What was E?
E is the triple bond.
Between what?
CC or CN. So yeah, I think we should go with it.
Ooh, you guys got it.
Hey.
Let's
sound
go.
like rude. I'm kidding.
That's good. That's good. Okay. Does that make sense now on how to read the IR and what that represents?
Yeah, I feel like I need more practice. I think Korean
No,
is really
I need more practice too. You can never do enough practice unless you're like me.
Mm-hmm.
yeah.
Because you want it to like be kind
But
of.
like I know where to like start now.
I also sent that like big PDF, has a bunch of them. I might have accidentally deleted the answer key though. I'll look for it.
And I'll send you this as an image as well, just to have a bigger picture of it if you wanted to print it out. But
I think it would be good for us to like copy it and like draw it ourselves.
yeah,
Or
that's best. That's best to copy and draw it yourselves, right?
add your own little things.
Yeah.
So we don't have a color.
Color coded and everything.
I feel like I've seen this picture posted somewhere.
Oh really?
It's best for you to just draw it by your hand, so you like can add little thingies to help you, or like like steal a picture but like add to it.
Okay.
Yeah. Yeah, I also saw this like picture posted like at a different server, and then like one of my students saw, and then they like sent it to me, and I was like, oh shoot, people are like spreading this image around.
Yeah, I think it was 118A. That's where I saw this.
Yeah. That's good.
I guess it's helping everyone out.
That's good. That's good. Like passing it on to future students.
Yeah.
Yeah, I'll send it to you so that if you wanted to send it to anyone, you could as well. But any other questions, Tanya?
Yeah, are you sure?
Yeah, I think I'm like pretty good. We only have 3 minutes anyways.
Oh yeah.
That's good. Okay, and I also have like other videos on YouTube. It might be scrambled, but like those might help to like go over like free radical halogenation and chirality and stereochemistry and stuff like that.
Yeah, I'll use them.
Yeah, of course. Yep, I'm glad you guys understand it now, and good luck on your quiz tomorrow.
Thank you. We'll let you know how it goes.
Yeah.
Yeah, tell me how it goes.
Take care.
Yeah, you too.
Bye bye.
Bye bye.